Welcome to this explainer. Today we're going to build your absolute ultimate cheat sheet for understanding the wild world of artificial intelligence. Look, whether you're coming from a highly technical background or you are literally just starting to figure out this whole digital landscape, this explainer is designed to be your practical handbook. We are going to decode the heavy jargon of AI so you can actually use these terms with total confidence in your day-to-day conversations. Have you ever found yourself just kind of nodding along in a meeting when people start throwing around acronyms like LLM or buzzwords like deep learning? Yeah, we've all been there. Well, the next time your boss or a colleague mentions an LLM, you are going to know exactly what they mean. We're going to break this massive, complex technology down like a set of nesting Matryoshka dolls. We'll open up the biggest concepts first and then reveal the incredibly specific technologies hidden right there inside. Here is our quick game plan for today. We're covering 1. The AI umbrella, 2. How machines learn, 3. Generative AI and LLMs, and finally, 4. AI and your job. Okay, let's jump right into section 1, the AI umbrella. Let's start with that outermost doll. Now, it might feel like artificial intelligence literally just arrived yesterday, but the concept actually predates the internet by decades. As far back as 1950, Alan Turing was already out there speculating about machines that could think. He proposed his famous Turing test just to see if a computer could successfully mimic human conversation. The official term, though, was born at a Dartmouth College workshop back in 1956, coined by a scientist named John McCarthy. And today, well, that foundational research has totally exploded, embedding AI into basically every part of our daily lives. But to really get it, we need to split AI into 2 very distinct categories. Those categories are artificial narrow intelligence versus artificial general intelligence. And here's the deal. We currently live exclusively in the era of artificial narrow intelligence, which is sometimes called weak AI. These are systems designed for one single, highly specific task. Think of the algorithm powering your GPS or the spam filter catching junk in your inbox. They are absolutely brilliant at what they do, but they literally can't do anything else. On the flip side is artificial general intelligence, or AGI. This is the classic sci-fi concept of a system with human-like cognitive abilities that can learn and adapt across any domain. But let's be super clear about this. AGI remains entirely theoretical right now. Moving on to section 2, how machines actually learn. So what makes narrow AI tick? Let's open that first doll to look at the real engine here, which is machine learning. Before machine learning came along, traditional software required developers to write out these explicit, agonizingly detailed step-by-step rules for a computer to follow. Machine learning completely flipped the script. It's a subset of AI that allows systems to learn directly from data and improve their accuracy over time without those rigid rules. Instead of programming a computer on exactly how to solve a problem, you just feed it data so it can discover the patterns all by itself. It's a total game changer. And there are 2 main approaches to teaching these machines. First up, we have supervised learning. This is basically teaching the machine by example. You train the algorithm on labeled data where you already know the answers. For example, feeding it 10,000 photos explicitly labeled as cats and not cats. The other approach is unsupervised learning. Here, you just give the algorithm raw, unlabeled data and let it freely explore to find hidden patterns. You might feed it a massive, messy spreadsheet of customer shopping habits, and the machine will just naturally group them into distinct customer segments entirely on its own. Now, if we open the machine learning doll, we find an even more advanced subset inside: deep learning and neural networks. We hear these terms literally all the time, but what exactly makes them deep? Well, to understand the deep part, we have to understand the network. Neural networks basically mimic how human brain neurons signal each other. They're built in layers. You've got the input layer, which receives the initial data. Then that data passes through the hidden layers, where artificial neurons process the information based on very specific mathematical weights and thresholds. And finally, the output layer delivers the final classification or prediction. So here is the absolutely crucial point. The deep in deep learning, it has nothing to do with deep thoughts or some profound understanding of the universe. It literally just refers to the geographic depth, the sheer number of node layers within that neural network. A neural network must have more than 3 layers, including the inputs and the output, to be officially classified as a deep learning algorithm. All right, section 3, generative AI and LLMs. Let's open our next doll to reveal the shiny new toy that has pretty much taken over the world lately: generative AI. See, traditional AI was mostly used to analyze existing data or make predictions, like flagging a fraudulent credit card transaction. But generative AI is entirely different. It creates brand new content, whether that's text, images, or even code, all based on natural language instructions called prompts. And unlike older enterprise AI, generative AI is incredibly accessible. Basically, anyone with a web browser can use it to draft emails, summarize huge documents, or write code without needing a single technical skill. The most famous form of generative AI, and honestly the one you probably interact with the most, is the large language model, or LLM. An LLM is a deep learning model trained on massive text datasets. Its entire purpose in life is to process human language and generate coherent responses. This is exactly what powers those incredibly popular tools like ChatGPT, Google Gemini, and Microsoft Copilot. So let's look at the actual mechanics of an LLM to see how it answers your prompts. Because LLMs don't actually think or know facts. Instead, they operate entirely on prediction. Step 1 is tokenization, breaking your prompt down into smaller units of text called tokens. Step 2 is contextual prediction. The model uses a highly advanced neural network structure called a transformer architecture to analyze the relationships between all those tokens simultaneously. And finally, the output. The LLM mathematically calculates and generates the most logical, probable next token in the sequence. It is essentially the world's most powerful autocomplete. And yet, because these models are trained on billions or sometimes even trillions of parameters across vast datasets that cover a huge chunk of the entire internet, they possess a flexibility that is frankly staggering. They can draft complex legal contracts, translate languages on the fly, and debug messy software. As Sam Altman, the CEO of OpenAI, recently noted, these models feel incredibly and sometimes intimidatingly intelligent. But you always have to remember, beneath that feeling of intelligence, it is really just recognizing patterns and mathematically predicting the very next word. Let's wrap up with Section 4, AI and your job. Let's open our final doll and bring this whole thing right back to you. Now that you know the jargon, how is this actually going to impact your career? Look, a lot of people are understandably worried about robots taking their jobs. But according to some deep microeconomic modeling from the Boston Consulting Group, between 50 and 55% of all U.S. jobs will be materially reshaped by AI over the next 2 to 3 years. And I want you to really notice the word there. It is reshaped, not replaced. When we actually break down this disruption, we see that task automation absolutely does not equal job loss. Roles are splitting into 6 distinct categories. Think about software engineers. They're in the amplified segment. AI augments their coding, making them way faster, which actually drives more demand for their work. Content marketers are rebalanced. AI handles the routine drafting so the humans get to focus on complex, high-level campaign strategy. Now, yes, there are roles that will be substituted, like some routine financial analysts, where AI replaces the core tasks and caps demand, which does lead to net job loss. But then there are limited exposure roles like physicians and teachers. Those jobs rely heavily on real-world context and human interaction that AI simply cannot replicate. So the crucial takeaway here is this. While BCG estimates that about 10 to 15% of jobs are vulnerable to substitution or elimination over the next few years, the vast majority of roles will persist. However, the nature of those roles is going to change. Because AI will handle the routine, repetitive execution tasks, the humans left in the loop are going to face much higher skill and cognitive thresholds. Basically, the vast majority of workers will simply need to level up their domain knowledge, their oversight skills, and most importantly, their daily fluency with AI. Which brings us to our final question. Now that you understand the nested dolls of artificial intelligence, the mechanics inside the machine, the difference between supervised data and generative LLMs, the only question left is how you are going to adapt. You've got the vocabulary now, so how will you harness these tools to augment your own future? Think about the mundane tasks you do every single day and ask yourself, which ones can you hand over to the machine so you can focus on being human? Thanks for joining me on this explainer, and I genuinely hope this practical handbook serves you well.